Good morning, good afternoon, or good evening, depending on your time zone, and welcome to the spring webinar program. My name is Peter Humphrey, and I am, as always, your host. Today, I'm very excited to introduce you to Jakub Pilimon, who is going to be talking about event-driven systems with Spring Cloud Stream. So, Jakub, would you like to introduce yourself?
Hello everyone. Thank you, Peter. So my name is Jakub Pilimon, and I work as a software engineer. Currently, I am an independent consultant. So I try to help companies in building better software and architecture, or at least I hope so. When I do not code, I run classes as a trainer in a company called Bottega IT Minds. Also on a blog, here is the URL, and my main area of interest are object orientation, domain-driven design, system development, and architecture. So today I would like to talk about building event-driven systems. So thank you all for joining this webinar. I appreciate your time. And first of all, the question is, why do we do our systems in an event-driven manner? So I think it's mainly because it helps us in delivering software in a loosely coupled way. So we have a producer and we have a consumer of events, and the producer doesn't know who the consumers are, and the consumers do not know who the producer is. So they don't even have to be alive at the same time in order for them to communicate if there's, for example, a message broker in between them. So first of all, it helps us in delivering loosely coupled systems. Second of all, it follows open close principle, right? Because we can add functionality without touching the code of the producing side. So we can build some new functionality upon an event emitted by the producer, and we don't have to modify that code from the producing side. But in my opinion, the most important reason why we do that is that our systems try, or at least they should try to solve the business problems that we are facing. So what is the business domain? Business domain is nothing more than series of events, of domain events or business events. So if we try to capture them in our code and represent as first-class citizens in our code base, it's easier to reason about the domain. So to me, it's the most important reason why we should build our systems in an event-driven manner. So we'll start for talking about how to find your events in your domain if you don't have them yet in your code base. So do not be worried if after half an hour we don't even mention the word microservice or Spring Cloud Stream or messages or something like that, because first half an hour we'll spend on finding our events in a normal object-oriented domain. And then we will try to rewrite this domain to an event sourcing persistent mechanism, which is basically a different way of storing our state. Then we will go to Spring Cloud Stream tool, which helps us in delivering event-driven systems. We'll talk a little bit about command query responsibility segregation, and we will see if it's difficult or not to build event-driven systems that have, for example, processes that spans multiple bounded contexts. If it's possible, if it's difficult, and how Spring Cloud Stream can help us while doing that. And by doing that, we'll see some architecture patterns and challenges that we have to face. So let's start coding. So I think that almost every domain that we are aware of, or at least most of them, has a concept of a user. So let's create a class named user, okay? And what I do at this point, when we have our concept identified as a class, I try to find the behavior. So I think we shouldn't be thinking at this point about data structures that goes behind this user or what kind of properties it has, but we should focus on what kind of behaviors it exposes. What is the construct? What are the methods? What are the signals that we can send to our object? And to do that, I recommend you such techniques like event storming or domain storytelling. We don't have time to cover them, but you can find many materials online about that. So let's assume you are done with that. We went through event storming session with, for example, business folks, and we identified that our user should have following behavior. For example, I don't know, we can activate our user. We don't know yet how to do that, but we know that we should activate him somehow. It has this behavior. So also, we can deactivate him if we can activate him. Let's say we can change his nickname to a new nickname. New nickname. Let's say we also can ask our user several questions like, hey user, are you active? Are you activated? Let's return false for a while to make it compile, because again, we don't care about data structures inside, we care about the behaviors. Similarly, we can ask him whether he is deactivated, and also we'll return false here. And let's say we can ask him, hey user, what is your nickname? It will be returning string, I guess. For a while, it's return empty string. So at this time, at this point, when we have our behaviors exposed, what I do next and what I recommend you to do is always try to think about invariants. By invariants, I mean what are the state transitions that our object allows us to do. So basically, these are a bunch of if statements in our model. Also, they can be found by, for example, event storming session or domain storytelling. When we have them defined, I recommend and I like to do the following. I try to capture them in a test specification. So for that I use, for example, Groovy. It's readable, so we can capture our invariants in a series of test cases. So let's say that we identified that, for example, the activated user cannot change nickname. There's the first invariant. The second invariant, for example, can be activated user can change nickname. The third one would be pretty simple. Let's say a new user can be activated, and let's think about it. Deactivated or activated user can be deactivated, of course. These are the state transitions that our object, that our user allows us to do. Let's say that activated user cannot be activated again because it doesn't make much sense, right? And the same with deactivation. The activated user cannot be deactivated. Yeah, so we have them defined. These are the invariants. So that will be the time to do proper TDD. So let's green refactor, but we don't have time for that. So let us write all the test cases up front and then go to the implementation part, okay? So we'll initialize a new user. User should have an identifier, I guess. So let it be UID. So let's actually create UID here in our code. It should be private final UID. Let us add it to a constructor parameter. I didn't add it. One more time. Factor. Okay. I think we will be needing a getter for that. So let us add the getter. So okay, we have a user, and the activated user cannot change his nickname. So given the activated user, when we try to change his nickname to, let's say, Barry, then our system should not allow us to do that. So let's say illegal state exception is thrown. But activated user, so user.activate, when we try to change his nickname to Barry, it should say, okay, my new nickname is Barry. So when we ask him, what is your nickname? It should say Barry. New user can be activated. This one is pretty simple. So when we try to activate the user, then it should be activated. Simple enough. then it's activated. Activated user can be deactivated, so when the given user is activated, when we try to deactivate him, it should be deactivated, right? Activated user cannot be activated. This one goes like this: user dot activate. When we try to activate him again, then illegal state exception should be thrown. And same here, given user that is deactivated, when we try to deactivate him again, then illegal state exception should be thrown. If we run those tests right now, I guess they will fail because we didn't implement anything. So let's run them, and let's jump to actual implementation. It's building, and they should be all orange. Yeah, so they are red. Let's go to the implementation, and so now we have the behaviors, and now we have the invariant called as a series of test cases. So now is the time to think about data structures and the actual implementation. So when we activate user, we should check whether it is already activated. If it is, we should throw this illegal state exception, right? If not, we can change state to activated. So let us create a new data structure. Let it be an enum, user state, I guess. Initialized, activated, deactivated. And at this point, we can say, okay, my state is activated, the invariant has passed. We need to have a field for that, private user state, and let us initialize it with initialized for the very beginning. If it passes, then the current state is, of course, activated, right? The same here. If we try to deactivate already deactivated user, then something is wrong. So we should throw new illegal state exception. And if not, we can change state safely to user state deactivated, right? Cool. Change nickname. So there was an invariant that says we cannot change nickname if the user is deactivated. So if it's deactivated, similarly throw new legal state exception. If not, nickname should be equal to new nickname, right? We don't have this nickname, so let us create that field nickname, and at the very beginning it can be empty string, I guess. Cool, so we have this nickname. We can return it when we are asking our object, our user, about his nickname. And two more methods, I think there's a typo here, is deactivated. So two more methods to implement, these are those. So it's activated, it's pretty simple. If our state is equals to activated, and same here, right? If state is equals to deactivated. Let's run the test again. I hope this time it will pass, or at least half of them will pass. All of them are passing, cool. So this is our domain model, but domain model is useless without any kind of persistent storage, right? So let's create a repository for that. So we'll create a new class. Actually, it will be an interface because we'll have a couple of implementation, okay? So we'll have a user repository interface, and it will be very simple. So it has, it exposes two behaviors. We can save a user, and we can load the user by, we can find him by, I guess, UID, right? So this is our contract, our user repository interface, and let us implement that with very simple in-memory user repo. So I think we can store him, we can store those users in a hash map. So private final map, hash map of UID as a key and user as a value. Users should be equal to new concurrent hash map like this. And this is pretty simple, right? When we are saving, we should just update the key, users put user get UID and user. And here also we are returning null if it's empty, if not, something which is under this key. Right? It should work. I will create a small test for that because soon we'll have different implementations, so we will need it. This one is trivial, so I guess the test will pass. Let's name it user repository test. And the test case that I see here is, I guess, should be able to save and load user, right? If we can do that, then our repo basically should be working. So let us initialize a new repo here in memory user repo, right? So given we need random UID to create a user, random UID, and we need some user equals to new user with this UID. And also we have to change his state. We'll, for example, activate him and we will change his nickname. So some user change nickname to, again, Barry, and now is the time to save the user. So when we try to save, our user save some user, and we try to load him again by this UID, then I guess loaded should be activated, and loaded nickname should be equals to Barry. Let's check whether it works. I hope it will be working. It's a really simple test. Yeah, it's green, cool. So I know it's pretty simple, this test, but we will be needing that when we will be changing this implementation to event sourcing. Basically, we want this test to be green, to be still green. Okay. So if we take a look at the user, at the behavior it exposes, like activate, deactivate, change nickname to, we can see that basically, as we have said, there is a behavior exposed as a message, as a method call. So the signal I can send to my object, protected by some invariant. If it doesn't pass, basically we are returning NCK to our client. So I'm sorry, if the comment you want to pass to my object cannot pass through. But at this point, when the invariants pass, all of the invariants pass, basically it's the equivalent of ACK. And here we have a state change. At this point, we are changing state. This state change will be later caught by, for example, if we are using Hibernate or any other ORM, this change will be seen by dirty checking mechanism and stored in our database as a SQL statement. So here we cannot deny that the comment has happened from this point because the invariant has passed. So at this point, there is an event as a past tense that something has happened. So this is a way to find your events in your application. These are basically the state transitions that are just after the invariant. So these are the events. This is the event, and how to find the name of the event. So I always try to extract this method. Let's go, for example, with the change nickname. The same here. This is the method. This is the behavior. This is the invariant, and this is the state change. So I try to extract the method from this point and try to name it. It's ACK, so I guess I can use past tense. So for example, username changed. So at this point, when we have this method, basically this name is the name of the event that we want to capture in our code. This is the name of the event. So now we have the event. Now we need the content of that event. What is the content of that event? The content of that event is provided for us for free by our IDE. So when I did extract method, everything that went here is the content of our event. So basically, I can say that our event, I have one big parameter here that is an event. So at this point we have only one parameter, but imagine there would be like 4 or 5. All of them would be captured in one username changed event. And here we would have a new username changed event, and the content is, of course, new nickname, and also it's good to have timestamp of every event. So I guess it is instant.now. So let us create this class, string new nickname instant when, and we can bind parameters to fields, and we will be needing a getter for that nickname. All right, let's go back to user, and here we can say event get new nickname. Now we can repeat that exercise with every behavior we have. So, for example, deactivated, we can say, okay, it's user deactivated, right? And here it will be new user deactivated. This event carries only timestamp. We can create that class and bind parameters to field. And similarly, we would have the same thing. We'll add this parameter here. We'll have the same thing with the activation, right? We can have user activated here. And basically, this is new user activated instant.now. So I think we can copy-paste user deactivated because it will be the same, and it will be quicker. So yeah, we have user activated. Here it doesn't compile. Why? Because we have to add the parameter to that method. So at this point, if we take a look, we have the behavior, invariant, and the ACK, the state transition, and the user and the event is being emitted here. So this is the way to find the event in our system. So by the way, let us check whether our test for user still works. If it's still green, I hope it is. And then we'll go through with the event sourcing. What exactly we have to do is we have to somehow get rid of that dirty checking mechanism that would be enabled by ORM, and we have to store our changes on our own. So what are our changes? Our changes are those objects, right? These objects represent the domain object that is being changed. So I think we can keep them in an internal collection. Let us create. We can create a marker interface for all of them. I think it can be called domain event. Event or changes equals to new array list. Right? Cool. We have to import the class. We don't have domain event, so let us create that. It will be an interface. And this interface should only provide us a timestamp of an event. So for example, instance occurred at. And now what we have to do is we have to implement this interface in our domain events. Implement domain event, and this is easy because we have the timestamp here, so we are returning when. The same with user deactivated. If we go like this and we implement domain event, this is similar. We can implement that method, and we will be returning when as well. And the last one, username changed, should also implement a domain event. We can implement those methods and return when here. So now what we can do, we have to import the list. We can, anytime the state is being changed, we can say that, okay, I have a new change at user activated. Same here, changes at user deactivated. So anytime someone has changed my state, I have to add this change to my internal collection of changes. Changes at event, here is named event, to make it similar, I will rename it username changed. Okay, cool. So why we do that? Because now we can ask our object if it's dirty or not, if it's changed or not. Whether it's dirty, we have to check if our internal collection is empty or not. So now is the time to create a second repository. You can copy paste that one, and we'll call it event sourced user repository. And this is the tricky part, because what we have to store here, in event source scenario, we are not allowed to store state, so we don't store user. Instead, we are storing only domain events. So list of the domain events from the very beginning when our object was born. So how it looks like in a real example, I had a slide that said how we are recreating state in event sourcing scenario. So basically, we go with the event stream, which is append only log of immutable events, and we have to have an initial state, which is basically an empty constructor, right? With this empty constructor, we apply against this object a first event from our log. So with this, in this case, it's user created. User created carries one information, that the name is John. So we are mutating our state from a return by this constructor, and we are mutating a field called name. And we are returning a new state, and we are applying the second event. So we are mutating state again. We are changing the active flag to true, and we are returning new mutated state. We go to the third event, and so on and so forth, up to the very end. This is basically what event sourcing is about. If there's anyone familiar with functional programming, this is basically left fold. So we are consuming the stream of events and producing the result. So we programmers should be familiar with that concept, because there is something which is called Git, and Git works exactly the same. Or databases, underneath they have transaction log, which is basically the same concept. It's nothing new. But how to implement that in our code? So let's think about it. We have user. We were storing state here. Now we are not allowed to do that. So what we have to do? We just have to append a new event from our user, right? When someone is calling save. So this is the dirty checking mechanism. If it's empty, we will not add anything. If it's not empty, we will add new changes. That's it. End of the story. So let's get new changes from our user. Get. I think it doesn't have the getter for that. We'll have to create that. Yeah, it will return changes, but I would like it to return immutable copy of that, so that no one can change it, right? So we have the new changes. We can have current changes, basically because we have them in our map. This is users dot get or default, because if it's empty, we want an empty list as the current changes. This is get by UID, user get UID, or an empty array list. What we have to do, we have to append new changes to current changes. So add all new changes. And we have to put those current changes in our map. That's it. But now we have to also inform our object, hey, you are not dirty anymore, so please flag your changes. Basically, it's the equivalent of flash in Hibernate, for example. We are flashing state where the object is not dirty anymore. So we'll create that method here, and it should say, I guess, changes dot flash dot clear, I guess. Yeah, dot clear. So we are clearing the internal collection of changes. And that's it. That was the easy part. The trickier part is how to recreate that state here. So this is basically this left fold that we have to implement, that we have seen on the slide. So I guess we can say that if our map does not contain the UID, basically we don't know that object, so we can return null. Right? Users get contains key. If it doesn't contain, return null. If it contains, please return user that is being recreated from all of the domain events from the very beginning. so this left false. So let us write a factory method for that. So user.recreate from UID, and we have to pass all of the events. We have to pass UID to initialize an empty a default constructor, but also we have to pass users get our list of events. We don't have that method, so we have to implement that. It would be static. We create some UID and list of domain events. And this is the tricky part in Java 8 because Java 8 doesn't support left false out of the box. We would have to play with that. That is why I prefer to use one-liner from Java slang here. And it looks like this. Java slang or collection list all of domain events. We can static import that. And basically, as I said, left false from the initial state, which is initial state is nothing more than new user from UID, and a method that will treat each event accordingly to its type. So this is basically the way that we know, okay, that was user activated. I should mutate my flag or my state. This is user name change. I should mutate string nickname. So this is the one method that should know how to handle each event. So I think we can call that method handle event, and we have to implement that method. It should be returned user, so mutated user, domain event as an argument, and yeah, this one compiles, and now we have to run this, write this method. So this is basically either a big if statement or a switch statement or in functional way. So let us keep it more functional. It would be a pattern match. So we have to pattern match our events. So we can again use Java slang. We can pattern match, and this is pattern match of three cases. Case one would be predicates instance of. If it's instance of user activated class, then we have to run a method that will mutate state. And we have this method already there because we did it even before talking about events. This is user activated. We did this method, we implemented that method before. This should be returning something, and here I mean that. And here we have to import. Yeah, it's not compiling because, I don't know why. Let's see. Because user activated should return mutated state, and at this point it doesn't return anything. So we have to change our method to return this, mutated this, right? Here and here as well, and also here, I guess. Where is that method? Here, yeah, and we have to return this because every mutation should return mutated state. Because we have to go later on with the left fault. Yeah, now it compiles, but we need two more cases from in here, right? So let us copy paste that. We need commas here, I guess. Yeah, and if it's user deactivated class, please run user deactivated. And if it's user activated, then please run, if it's user name change, please run this method, right? Here we have to change to user, my God, to user name change. Okay, hopefully it compiles. This is what I like in functional programming, but when it compiles, there's a big chance it will work. So let's see. Now what we can do is we can go to user repository test, and we can change our repo test to event sourcing, new event source repository. And now, very important time. Let's see if it works or not. If it's green. Hey, it's green. So as we can see, we implemented event sourcing with a couple of lines. Of course, it's in memory, but it could be easily saved to a database, like in JSON, this domain event. So this was fairly easy. What is the benefit of having this this architecture? It's not architecture, but this pattern. So first of all, if we take a look at this slide, there is, for example, there is this append-only log of immutable events. So this is natural audit log of our domain, right? There is user created, user activated, user changed, user name changed, user deactivated, and so on and so forth. It's natural audit log. Plus, this is an audit log that we can prove because this is audit log from which we can recreate state. So it cannot be invalid. There's one single point of true. So this is one thing. Second thing is that there is nothing preventing us from reading the state, for example, up till this point. So we can go back in time with our state, just as we can do while we do checkout from Git from historic commit. This is the same pattern here. So if we go to our office on Monday and see a bunch of exceptions on Sunday, and we cannot replicate that bug because the state has changed, we can easily recreate change from Sunday by reading the event stream up till Sunday. You know what? I will try to implement that because it's fairly easy in this scenario. I think we can copy paste that method, and we will add a new method that will recreate state from the specific timestamp. So we'll find a new user at when. Maybe it's not a good name at timestamp maybe. Yeah, this is basically this should be looking same as the previous method. But we will not consume the whole stream, but we have to cut our stream at some point. So we can do stream, and we can filter our stream. This is event, and we are interested in events that happened not after the timestamp, so before timestamp or at timestamp. So I think if we write like this, events.occurred at is not after timestamp, and we collect that to list, collect.list, I think it will work. To prove that, we can try to write a test for that. So I think we can copy paste this scenario, and we will play with time a little bit. So I guess this is named should be able to load state from a historic timestamp. So given the ID and some user is activated, user changes his name, we are saving the user, and let's say 1 second has passed. It's not a good idea to use sleep in a unit test, I know, but just for the sake of this example, and some time has passed, and let's say the user changes his nickname again, change nickname to John, we don't need that, then basically if we try to load the user again, so find by UID, and this is basically current state, so get nickname should be equals to John, but if we try to load state from the history, so find UID instant dot now minus millis 1 second and a little bit like this, I guess. Then I know what's happening because user repository is in the interface, so we have to cast it here like this, and now we can use our method. And our state from the past says that okay, nickname at this time was Barry. Let's run this test. Let's see if it passes. If it passes, then we will implement it basically going back in time. Oh, it's not passing. What happened? Expected John and should be Barry. Here John and should be the current state should, because we didn't save our user again, right? So we have to, of course, when we change the name to John, we have to save our user in our repo. Some user is named, and now I hope it will pass. Yeah, fingers crossed. It's green. Cool. So this is the way to implement event sourcing, basic event sourcing in just in memory. Of course, we should do that in pure in normal database. Now is the time to think what we can do with those events. So, for example, we could emit those events to some external component, and we could create a scenario like this: that we have user service, basically the service that we have just created, and some other service called UI and message broker in between. So we'll try to implement that right now. What we will do is we'll create a different system, UI, and for example there we could store, we could get those events and create some reporting mechanism. We could create SQL, the normalized views in order to have fast reads. We could create hash maps to have very fast reads. We could create Neo4j graphs, for example, to have social connections between our users, and so on and so forth. This is basically the concept called common query responsibility segregation, and it says that not always the model you use to write state to your database is as performant as it should be in regard to the situation when you read the state from your database. So if you want to know more about it, there is a bunch of presentations on YouTube, also on Spring Doc. There is also a famous Twitter story, because they actually forgot about that and they used third normal form in both reading and writing tweets to the database, and third normal form is optimized for write to database because it doesn't have redundancy. So this is basically what we will do right now. So to do that, we'll create second service and we'll connect them by Spring Cloud Stream. Okay? So Spring Cloud Stream is a marvelous tool which helps us in delivering microservices, Spring Boot applications that basically talk with each other by the means of infrastructure. That is actually a very important step, because it's so easy to use that we cannot be wrong with Spring Cloud Stream. So it operates on the abstraction of a channel. So the channel is the abstraction that connects to microservices by the means of message broker. And Spring Cloud Stream comes with the 3 predefined classes that helps us enabling and to connect to some channels. So first of all, it's source. I think it's this one. Source says that I connect to one message channel, which is output from my application. That's why it's called source. So basically, I'm just a producer to one event stream, right? There's also a sync class, which is basically similar, but in other way around. This is one input channel, so I subscribe to one event stream. And there's also processor, which basically is both. So processor, Spring Cloud Stream here, which basically extends source and sync. So it has one input and one output channel. So what we have to do is we have to enable here. This is the first step to use Spring Cloud Stream. We have to enable some channel, binding to one channel. So our binding in user service will be source, because we are producer to one event stream, source class. Yeah. Import class. Yeah. So it was the first step to enable binding to source class, which has one channel named output. What we have to do next, we have to go to the properties file, and we have to say that dear Spring Cloud Stream, I have bindings, and my bindings to the name of the channel, which was output. Destination will be the name of the, for example, Kafka topic or RabbitMQ exchange. Let us name it users, for example. So this is the way where we were saying that output abstraction, the channel, which is an abstraction, is implemented by some concept in our infrastructure, in our message broker, for example, Kafka topic, okay, or RabbitMQ exchange. This is the second step. The fourth step is to check whether we have something on the class path. If we have Kafka start on the class path, then Spring Cloud Stream will try to connect to Kafka topics and users. If it's Rabbit, then it's Rabbit, and we can easily play with that. So it's like having an interface in different implementations. It's really cool. So the class path checked, enable binding checked, and application properties output destination user also checked. Now we have to run some code that will let us create messages and send the messages to the user's topic in Kafka. Okay, so we have to create a new class. I will name it event publisher. Let's say. Let's make it Spring component, and basically it will have one method, I guess. Public void send event, domain event. I think it's a good place to log that event as well. So let's have SLF4j log info about to send an event, right? And what we have to do is when we announce the method with this publisher to channel source output, then anytime we call this method, Spring Cloud Stream will deliver this method to deliver the return parameter from that method to this channel. So we have to return that event. Yeah, this time it will work. Now we can play with that, and to do that, I think a good place to publish those events will be in event source user repository. So when we are storing them here, we can also here inject private final event publisher and add constructor parameter like this. Yep, we have event publisher, and we have to make it Spring component, I guess. Spring component, cool. And for every new event, we can also publish that to Kafka broker. So new changes, so the pending changes for each event publisher, event publisher, send event. I think we can replace that. Yeah, yeah, it's much more nicer. Yeah, so we can publish the events, and the last thing we have to do is we have to somehow create random users so that we can see something in our output application. So let us create random users. It will be random ID. Let's say we will activate this user. We can also, I guess, change nickname to name plus new random next int of 10. It's not very humanish way to name people, but just for the sake of the example, okay? And we have to save the user as well. So we have to inject private final user repo here. It has one implementation, which is Spring component, so it should be okay. User repo, and we have to save user, and this will generate two events, right? Two events to Kafka, and you know what? There is a time to run Kafka, I guess. So Kafka needs Zookeeper to work. So first of all, we have to run Zookeeper, and then we will run Kafka broker. So we can run Kafka with this script. Hope it will work, because there are some problems sometimes with Windows and Kafka. I think it's connected. We can go back to our application, and basically what we can do right now, we can run this application. These random users, no one calls this method. So I guess what we can do, we can make it scheduled. I guess every 2 seconds we'll create some users. We have to enable scheduling here, right? Cool. Now we can run this, and I hope it will connect to Kafka and will send some random events. Not random, but events connected with that code. Let's see, the log statement is very important. It's trying to mapping something. Yeah, it's connected to Kafka, and yeah, we are sending something. See here, we are sending some random events to Kafka. So it connected to Kafka successfully. We didn't have to do anything. So Spring Cloud Stream leaves us without even thinking about all of the infrastructure burden that we need to do to connect to the message broker. Of course, we can control anything if we want, but if we don't want, there will be a bunch of default parameters. It's really cool. Now is the time to go to the second application, basically, which will be this UI application for users, and we can recreate this exercise here. So we will connect to Kafka broker, but we have to enable binding, and this application will be synced to our it will be synced in our case because it will connect to one channel as a listener, so it is a consumer of one event stream. What's more, we have to go to application.properties, and we have to say, view Spring Code stream, I have bindings, my channel is named input, because if we go to sync, we can see this name input, and destination is user. So there is the place where we connect those two applications, right? By this parameter, users. It will connect to users topic in Kafka if we have proper class path, but we have Kafka. So this is checked, this is also checked, and enable binding is checked. The last thing we have to do, we have to implement a method that will be called every time an event comes. So we can name it public void, I don't know, handle event, domain event. Here, and you know what, we can copy paste all of the events to make it quicker from the previous application. Domain event, user activated. Here, yeah, we can have it here and copy paste it. We don't need that, I guess. Copy paste it to our applications. Yep, and now we have domain event, so we can go and let's say we can log this event for a while. So this is the place where we will be handling events. Info receive an event, right? This doesn't say anything unless we allow to do this with this annotation. So this annotation tells Spring Cloud Stream to run this method, to invoke this method every time there is something in our channel, and we have to specify channel, of course. This is stream listener to channel input. Let us double check. This is input channel to users, and in our first application, we should have output channel to users. Yeah. So I guess if we run this application right now, it should be getting events. So let us run it. Basically, this would be the place. I can make it smaller. Yeah, this would be the place where we can play with our events, right? Yeah, we are getting events. You see, every 2 seconds we are getting some events. So how easy it was to connect two applications with Spring Cloud Stream. And the beauty of that is that if we change two applications that have different class paths right now, like RabbitMQ binder, it will talk with RabbitMQ. It's really cool. But this is the place where we can play with our events. So we can do reporting, we can do complex event processing, we can do event streaming, we can do SQL normalized projection, so read models, anything we want. We can have multiple projections of that event stream. This is the whole idea of having event-driven systems in the first place, right? So we have it connected. The beauty of that is you didn't have to do that much regarding infrastructure of our broker, right? I just run Kafka, that's it, and I click some code. This is provided for us for free. So what we can do, and what I see that teams are trying to do nowadays, they try to implement complex business processes in an event-driven manner. Let us say we have a process like this, that when user is deactivated, the payment has to be cancelled, and when payment is cancelled, shipment has to be cancelled, and then the email has to be sent, and so on and so forth. This can go forever, right? There's a complex business process that we have to implement. What I see that people try to do is they try to implement it like this. Like we have a user service which emits an event, second bounded context or second Spring Boot microservice gets the event, processes it, and sends another event. That other event triggers yet another event, and so on and so forth. This is so-called event waterfall. This is nothing that this brings us any good. This brings us no good, because how I can now track this process, how I can change this process, how a new developer, can come and say and answer to a question, what the process of user activation looks like. It basically spans for 5 bounded contexts. It requires synchronization of 5 teams. It requires knowledge of 5 teams, and basically the maintenance of that is terrible because any change requires, again, couple of teams, couple of deploys, and so on and so forth. So this is not a good idea to do. The better idea is to have something in the middle. So I recommend this kind of an architecture pattern, which is called process manager. This question mark, this big question mark in the middle is basically something which is called process manager. You can read about it, for example, in enterprise integration patterns, fairly well known. So what we can do here is we can react by getting an event in our process manager, and then we can span multiple commands or events to different bounded contexts. These commands here can be REST calls, or they can be also messages to a message broker. It doesn't make any difference. But when we want to change the logic of user deactivation, we have to touch one component here. We have to touch the big question mark. And for example, when we want to see how the user deactivation process looks like, we have to go under one code base, provided there are like good APIs here, and here for canceling and sending emails. Imagine that any email that has to be sent in our domain will be processed by this team by event. So this team will only have to run event handlers for every domain event that requires email. So basically, they will hate us soon, or they will be flooded with change requests. It's better to run an API here that says, okay, if you want to send email, invoke that endpoint, or send me this message via message broker. That's it. So to cut it short, do not implement business processes in an event-driven manner for event waterfall. We can do better with this, and the cool thing is that Spring Cloud Stream helps us in writing these process managers, and it's very, very easy. And the last thing I want to do is to write this process and to implement this process in our UI application. So let's say our UI now it becomes we can basically close it. You see it works. Now the UI, let's say it becomes our process manager, okay? So what UI has to do right now, it has to connect to 1, 2, 3, 4 channels, right? 4 channels. So it can't just say enable binding sync because it's not sync anymore. But we can write our own classes that specify what channels do I connect to, what channels do my process manager connect to. So yeah, let us create this this class. It's gonna be it's an interface. We can call it channels, and here is the place where we specify the channels that our application should bind to. So it's like more than sync or source or processor, but for different cases, more complex cases, right? So we know that our channel, our application should listen to events from users. So this should stay, right? So let us say input. I have one input channel called users, and it's basically a subscribable channel named users. I have also one 3 output channels. One of them is called payments, let's say. This is message channel, payments. We can copy paste that, not too much. And we can say that instead of payments, we have different output channel, which is shipments. Okay, I misparented here. And again, the last channel would be, I guess, communication. So one more time, one input channel called users, 3 output channels. One of them is payments, and then shipment, and then communication. Okay. If we take a look one more time at the slide, it's basically like this: payments, shipping, and communicator, and user service. we are listening to user service, and we are talking to payment, shipping, and communicator. So now we have to go here and say we are not enabling channels for bindings for sync, but instead we are using our channels. Okay? And now Spring Cloud Stream will try to identify those channels. But second thing we have to do, as we remember, we have to go to properties file. And basically, we don't have input channel right now because it is named users. We named it. We used to name users. This is basically here. Right? This is here. But we also have 3 more channels. 1, 2, 3. One of them is called payments. And let us say it will be Kafka topic payments. And the same here with shipments and communication. Okay? So this is shipment, and this is shipment. And here, I guess it will be communicator, communication. So let us double check, communication, shipment, payments, users. Communication, shipment, payments, user. I think we are good to go. Let's go back to this application. So now, what we can do is anytime when the domain event comes and it is event which is user deactivation, we should start the process, right? So if event is instance of user deactivation, user deactivated, then please start the process. There is nothing wrong here. I think it should be like this. Right? Cool. Yeah. And the beauty of Spring Cloud Stream that we can also easily test that. So let us first do the test. We can create tests for our code base. Let us call it end-to-end test. We can put it here. It will be Spring Boot test, and context configuration will be, of course, our application class. And loader will be default Spring Boot context loader. So I think that the behavior that we have to test is as follows. If when user is deactivated, then 3 commands are thrown. It should be saying payments is the channel, command to payment channels from, and so on and so forth. But to make it quicker, I will just name it like this. And now the tricky part. So we can use our channels here. This is thinking. So we can use it, and in the when section we can simulate that something comes to one of our channels. We have one input channel called user, so we can say, hey, when on the channels named users, someone sends a message, new generic message, and it is new user deactivation at now, then basically 3 outgoing commands were thrown. How to check it? This is really cool, right? We can simulate that something came to our system, but we have to check whether something was out from our system as well, right? So how to do that? Spring Cloud Stream comes with the bean called message collector. Yeah, message collector. And what we can do is we can collect any outgoing message in a blocking queue. So we will have 3 blocking queues, 1 for each channel, with each outgoing channel. So we should have blocking queue payments, blocking queue, I can copy paste that, blocking queue shipment, and blocking queue communication. And in the before section, the setup is equivalent of JUnit before. We can initialize those. So payment is telling right now message collector to store any outgoing message for channel payment in my blocking queue payment. The same I will do with the shipment for channels shipments. And the last thing, communication, message collector dot for channels communication. Really easy, right? Isn't it? We are now good to go with the assertion. So we are expecting that on payment channel, if we pull that blocking queue and we cast it brutally to string, this string will contain, let's say, cancel payment command. I know that the command should be also an independent class, but to make it quicker, just we'll send command as strings. Okay. The same we have to do here. That shipment pull a string contains, let's say, cancel shipment. I hope this was the process that we are implementing. And communication, when we are pulling this blocking queue as string as well, it contains send mail. When we run this test, I think it will fail because we didn't implement anything yet. But just we will check whether the context is up and if everything is okay, and the expected failure is there. So we are expecting this to fail, right? But something else failed. No being named input is defined. Why so? It says that there is somewhere channel called input, and it shouldn't be like there because all of our channel names are named users, payments, shipments, and communication. But here, when you are listening to a stream, it still says sync input. It shouldn't be like this. It should be users, right? Now we can rerun our test. And now the context should be up, and the test should fail. This is not this. This is not this. I run the application. Excuse me. We run the test.
Hey, Jacob.
Yes?
Yeah, Jacob. One of the audience members was saying you had a typo on payments.
Payments. I don't see typo.
Maybe he fixed it. It was on number 28. He said.
28.
Should be payment equal. Like payment equals message collectors dot for channel dot payment.
So it's the test. Yes, thank you very much. It is like this. Good call. Good catch. Thank you very much. It should be like this.
All right, whoever that was, send me your Twitter handle and I'll get you a free T-shirt.
Thank you. So now we are having null pointer exception, which is, I guess, expected because we are running contains on an empty thing because there's nothing from the outgoing command in the payment channel. So if we finish this this implementation here, I guess we will be needing a new class that will be able to publish to channels. We can copy paste from the previous examples from the users, event publisher, and we can go and have it also here. Let's say it's command publisher. Right? It's command publisher. One method will be for channel users, not users, but payments, and it will be named send command to payment. And we already assumed that payment, that domain event, that we'll be sending command in strings. Also, we have to check that. It should be command. Yep. And if we copy paste that 2 times, we should have here shipment. I hope I'm not having a typo right now. Payment shipment. Send payment. Send command to shipment. And the last one, send command to communication, right? Send command to communication. So this is communication. Yep, I think we're ready to go. Communication, shipment, payment. Send command to payment, shipment, and communication. No typo, I guess, here. Now I will be much more careful. Cool. So we can inject our publisher here. Find out how did I name it? Command publisher. Command publisher. We can add constructor parameter, and here we can say, hey, if user was deactivated, then I have to do several things, right? I have to cancel payment, and I have to also cancel shipments so that he doesn't get anything for free. Cancel shipment. Also, we have to publish a command to our communication. Send mail. It's stupid, the name of the command. Excuse me for that, but I will leave it like this. Yeah, let's run the test again. This time I'm expecting it will be green because we implemented the process, right? Let us, yeah, it's green, cool. So to double check that, we should run a different test, right? We should say that when user is activated, no commands are thrown because we don't know we don't want to cancel payment when user is activated. No commands are thrown. And user channels send user activated message. Then basically we can get rid of that, and we can say that payments is empty. So the outgoing command for payment is empty. Same with communication is empty, and same with shipments. Let's run this test. I hope it will pass. This is basically how easy it is to test and implement a simple. I agree that it's a simple process manager, but it's really cool that how Spring Cloud Stream enables us with such tools like this message collector to check whether our black box gets an event and returns some comments. So that would be it, I guess. There is much more to talk about scaling, horizontal scaling, and partitioning and failover that I already talked on Spring blog. You can find it, but we don't have time for that. All of the code that is there will be shared and will be soon at my GitHub account here. If you have any questions regarding the code, regarding the presentation, any feedback you want to provide, you can drop me a line here or catch me here at Jakub Pilimon at Twitter. I would like to thank you very much for your time. I appreciate your time. There is a question I see. There is the first time I see questions here. Which version of Spring Boot? I think 1.7. Let's check it. 1.57. 1.5.7. So one more time, thank you very much. I appreciate your time. Thank you, Peter, and I'm done.
You're welcome. You're welcome. Yeah, Jacob. So we've just got a minute or two left here before the the presentation system is actually going to shut us down. So this is a really good time, folks, to click on the resources, attachments, and links section of your user interface. As Jacob mentioned, the source code, a number of people have asked, the source code for this webinar is located at github.com, pillow.pl, right up there. You can see the URL. We'll put a link to that on the replay page. And since we unfortunately don't really have much time for questions, what we're going to do is Jacob is going to answer your questions, and we're going to post them as an attachment to the webinar replay. So the same URL that you use to register is the same URL that that the replay is on, and we'll have answers for you hopefully by the end of the day, latest probably tomorrow, depending on what Jacob's got going on today. But we'll get those answers for you as quickly as possible. And then if you are looking for Spring Cloud Stream bits, obviously there's in the attachment and links section. There's a link to the Spring Cloud Stream project page where you can find the Maven and Gradle coordinates. If for some reason you're stuck behind a firewall or 20 layers of proxy servers or on some sort of closed or military network, and you really actually need HTTP downloads, you can get them off of repo.spring.io, but we don't make it easy for you, to be honest, but it is possible. So encourage you to use Maven or Gradle whenever possible, for sure. Let's see. We have a minute or two left. Now would be a great time to give us some feedback. If you would take a moment to go to the votes section, there's a poll in there, and then you can also give us some feedback in terms of rating our presenter and telling us what you'd like to see from us in the future. So yeah, please, we'll take, I think we've got enough time for just one or two questions. I'll take one of the most top ones. But yeah, while we're doing that, if you could please do the poll where it's under the votes for polls, and the rate the feedback, that would be great. Very much appreciated. So Jakub, we just have time for like one or two questions. Is Kafka the default stream system? Like, how would we switch to Kinesis or ActiveMQ?
So as I already mentioned, that Spring comes with some predefined binders to, for example, Kafka or RabbitMQ. I don't know about Kinesis, but I think there are like outgoing implementation regarding, for example, Google PubSub. The thing is that the only thing we have to do is we have to change our class path to different binder. That's it. That's the pure beauty of Spring Cloud Stream. And depending on how many binders there are implemented, I myself used two of them, so Kafka and RabbitMQ. But as I said, there are already ongoing implementation of different ones. I don't know about the status, but this is the way to change the default stream system. So there is no such thing like default stream system. You have to provide some binder on the class path.
Cool. Okay, we're literally going to get.
That's one more thing.
Yeah, we're literally going to get set off in 1 minute. So let's wrap it up. Yep.
Okay. Just wanted to mention that the code is not there yet on my GitHub account, but it will be there in like 1 or 2 hours after the session, okay? Because it's just written, so I didn't have time to put it on there.
Very good. Okay, thanks for that. Yeah, all right, everyone. So we're going to be kicking off. Thank you so much, Jakub. Really appreciate your time and the effort you put into this. So check out Jakub's GitHub repo. And if we didn't get to your question, we'll have answers for you today or tomorrow at that same link that you used to register. Join us again really soon. We're going to be kicking off a 5-part series from Michael Plud at InnoQ in Germany on domain-driven design, which is going to be awesome. So keep an eye out for that. So, we'll be posting it on the Twitter blog. Thanks, everyone. Have a great day, evening, or morning, depending on where you are. And join us again soon for another webinar on the program. Jakub, thanks a lot.
Thank you. See you soon. Bye-bye.